Okay, frame design. So these workshops, we're going to be doing them once every week, and then we're missing February 3rd because we don't have the space for that week. But it's going to be about an 8-week long workshop course, I guess, and we're going to be going over practically all the components that you can get on an aerial vehicle. So today we're going over the frame, which is usually the simplest part of it, and you have the most ability, the easiest ability to change it. You can make your own on SolidWorks. You can find a lot of things on Thingiverse. You can also buy different frames online. But we're also going to be going over motors, the ESCs, batteries, flight controllers, FPV, video transmitters, receivers, all that sort of stuff. So that hopefully next term, if you guys are all still in the club, we're going to be having you guys build your own quads. And that's going to be, we're going to be hoping to have you build them for about the price of a textbook. So that's the goal for this whole series, is that you can have the knowledge to go and build your own quadcopter from the ground up. So the first week is going to be on frame design. You want to hit the next one? We're going to be working on building an acro or a 250 class racing quad, because I think a very cool thing would be to have all of you guys have your own 250 class racing quads, and we can make our own FPV league through the Robotics Club. So a racing league, we can hopefully get sponsors, hopefully get people to, or courses that we can go on. So that's the goal. A 250 class racing quad is defined as 250 millimeters across the diagonal from motor to motor. So that one, you see the orange one right there, you want to hold that one up? That's a quad Carl designed. He built it for about $200, and that is what is a 250 class quad. That's, they're going to be light, and they might not have as much power as, say, the octocopter over there, but they probably can get up and go. Considerations you want to take into mind when you're building a frame. You want to take in mind how big your propellers are going to be. Those ones, Carl, what size are yours?
5-inch.
5-inch. So he has 5-inch propellers. One of the mega quads we have in the club is 16-inch propellers. So you really need to consider what you're dealing with, what kind of beast you're dealing with. Also, battery placement. Batteries tend to take up a lot of space, and you really have to make sure you know where your battery is going before you just make some random quadcopter on SolidWorks and print it out, and then you have no idea where everything's going. Wiring is a big thing. If you look at the octocopter in the front, you can see all of the wires are braided into the center, so that they don't get in the way of the spinning motors, and they don't get in the way of any other moving parts, so they don't get cut or any motors don't go out. So you really want to take into account wiring placement. As an ME myself, usually I don't think of that because I'm building a frame, and it's brought me into some sticky situations before, so that's a big thing. And then also video positioning, where you want your video recorder when you're doing FPV, so that you can see everything in front of you, so you can get a wide field of view. And we'll also go into if you want to have it on a servo, so you can actually adjust the angle that you're seeing. Next slide. So differences in racing quads. You can have a quadcopter or an octocopter. Those are typically the two types you're going with. A quadcopter are all the ones you kind of see in front of you for the most part, 4 rotors. The one that's in front of Josh and Sam, that's the octocopter. If you look at it, it doesn't have the blades on it because it's going through some tuning right now, but it has motors on top and bottom. Really what you get from an octocopter is a lot more thrust, a lot more power, so you're going faster. But the trade-off is lower battery life, and it's expensive. Like, motors are a big investment when you're going into quads. The orange one, those motors cost, what, $50 for the 4 of them?
Yeah.
So you're looking at about $15 per motor. So if you go to octocopter, you're looking at a $60 increase. So it's really, one of the main themes that you're going to be seeing is you can do it, it's just going to cost you more money. That's really the thing, because there's a lot of off-the-shelf things that you can buy. The vibration dampening. Yeah, do you have a question?
If we're going to race these, are we going to have two different leagues, a quad league and an octa league?
Everything's in the same. It's 250 class, right? Yeah.
So everything actually, the racing isn't a huge thing, but it's actually fairly new. It hasn't existed except for the last year or two because the technology hasn't existed. So everything exists in the same thing. The power trade-offs for having less battery life usually end up being equivalent to, it's one half dozen of the other. It's more complex, obviously, to build a rotor, but you trade that for more power with less battery life. So.
And sometimes when you're racing, you need more battery life, so you get a bigger battery, and then that weight is actually a trade-off between extra thrust because you're adding weight to the actual quad itself.
Okay, cool.
Yeah.
Thanks.
So vibration dampening, all these are flight controllers, and that's what flies the quad. That's what sends the signal to the motor, the ESC, to the motor to make them spin up. And when you're flying, and those rotors are spinning at really high RPMs, that flight controller experiences a lot of vibrations, and it sometimes that'll tell it that it's not stable, or something to the effect of that. So you might want vibration dampening on here. So I'm going to keep pointing at the orange one because that's the kind of thing we're looking at. It has a vibration dampening plate, so if you want to just kind of tap on the top of it very lightly, it has like little vibration dampeners along. You can do that, but also, Levi, you want to take note of what happens if you don't dampen it?
As far as flight control?
Yeah.
Basically, I don't know, it just makes it harder for the sensor to record what's going on with the levels, and the levels are bouncing all over the place.
Yep. So you lose a lot of the control, I guess, but I mean, you still are able to fly if you don't dampen it. And then also landing gear. I'm going to point you to this one over here. This has no landing gear. All you're doing is just landing, you're just doing a long landing every time you land. The benefits of that is you're doing a racing quad. You're not really wanting to land it, right? You're trying to get around a course as fast as possible. So you might deem it that you don't need landing gear. Whereas if you look at the octa quad or that one, they have the little 4-prong landing gear so that when you take it down for landing, you might not break any of the equipment. So when you're building your frame, you should consider, do I want landing gear? Do I not want landing gear? What is going to be the trade-offs if I decide not to have landing gear and I'm just bottom landing it every single time? Because I've seen that one flip a lot of times. And we've broken a lot of stuff on it because of that. But it's not also meant to race, so there's that. Next slide. So then component placement. When you're designing your quad, you want to think about where all the components are going. So I'm going to send out these PowerPoints over the members list, so you'll have these PowerPoints. And this is basically all the main components you're going to be looking at. You're going to be having your motors. So this is your main center computer, flight controller. Then it's going to go off to your 4 motors and your 4 ESCs. Then you're going to have your camera in the front, looking forward, and then usually maybe your radio transmitter and your video transmitter in the back. So when you're designing your own custom quad, if you want to do that, I suggest doing a similar component placement diagram where you would put down your flight controller, you know where that's going to be, and you put down where your 4 motors, or your 8 motors, or your 4 ASCs, 8 ESCs are going to be, then put down where your camera is going to be, where your transmitters are going to be, put down where your battery is going to be. I didn't include that in this, so that you really know what you're dealing with when you're building your quad. That you're not going to get everything printed, you're not going to receive it online after spending $40, $50 on it, and realize it's not what I thought it was. It doesn't have these certain components. So this is a very good, Levi was saying, this is talking about start most of your quads, isn't it?
Yeah, generally, just bubble diagram it out where I'm going to put everything, so plan before I put the hole in and everything. So.
Yeah, and so this is a very good starting point, I'd say. Go right next one. You want to take this?
All right. So frame specifics, I think you touched over this a little bit. Mostly camera, you want to be thinking about whether you want to put a servo in or it's just going to be a base camera. But this frame right here is a 250 tag. It's got just a little plate up there for mounting the camera. We have some throwing servos in there. Main thing to consider now is materials. You see we got the 5 main things that people are building out right now. Plastic, 3D printed, carbon fiber, PCB, which pretty close to the same thing. Aluminum, and then basswood and balsa. And pros and cons of each and all of the different ones. Plastic 3D printed is inexpensive, most commercially available. You got a lot of different replacement parts out there. Mid-range in weight and strength, and it's the only one that comes with a lot of flex, and that's usually a good thing when it comes to like vibration dampening. So that's one thing to consider when you're looking into plastic or whatever. Cons, breaks easy, low crash survival rate. I've crashed these things a lot of times, and the plastic ones, they snap right away.
So the orange one over there, we were flying it, what, like a couple of weeks ago, and someone flew it into a tree, and it fell down and broke 2 of those arms off. And Carl has the model for that and just printed off two new arms and was able to use it to film some videos and stuff like a week later. So
that's one of the benefits of doing a 3D printed frame or something like that, is you can basically print your own replacement parts. You don't have to wait for more than a couple hours to get your stuff up and flying again. So.
Like those arms, you can 3D print at the library for about 55 cents, have about a day lead time. So, I mean, if you break something, you're looking at getting back in there about a day for 50 cents. So, it's not bad. Continue, sorry.
Carbon fiber. Low weight is the main pro of that one. Is generally they make it thinner, so it's still a little bit brittle and breaks, and then no flex really. Carbon fiber is usually expensive unless you're building it yourself. Like these frames, you buy them like $20, but sometimes when you get carbon fiber, they run like 50 to 100. So PCB, pretty much the same thing. It's electrically simple. One thing I would say is that they're difficult to repair. Like,
Whose yours is that?
what I got back up there.
Can I hold that one up?
If you look at it, it's just one solid piece, and basically if anything breaks in here, the whole thing's trash. So, just one thing to consider. But yeah, but it's inexpensive. This one's like $12 for this frame, so it's not too bad. Other than that, aluminum, there's not a whole lot out there. Basswood and aluminum really is mostly just like, craft stuff. Just a couple things out there in the market right now. Aluminum definitely is the strongest, but high weight. Basswood, I recommend it personally, like especially when you're starting out, just because you can build and experiment, and it's like, I don't know, this is like basswood for probably like $4, $2 frame, so.
And also in the robotics lab, we have a lot of wood components for building frames. So if you want to go in there and just start messing around, we have a lot that you can just split glue together and throw motors on. So that's just that. It's a kind of cool project. So then, yeah, so for fabrication of it. So say you have a model that you made, you have something online, and you want to actually get the physical thing itself. If you go through SolidWorks, which all of the engineering computers in Dearborn, Bachelor, all of them have SolidWorks on it, so you can go in there, 3D model up something, and then just convert it to an STL file, send it to the library. We have some 3D printers in the box lab, but they usually don't work, so I take that with a grain of salt. But you can just send it to the library. They have, as I said, about a 2-day turnaround time, and it would cost about $20, $25 to 3D print like a frame such as that one. Also, you can go on Thingiverse. If you don't have experience with SolidWorks, you don't have experience with AutoCAD, then you can go on Thingiverse, just download the files yourself. Am I correct in that, saying that? Yep. And then anything else to say?
Yeah, there's a lot of, so Thingiverse is essentially, if you don't know, it's a big open source community that creates 3D models of things that you can generally print or laser cut. And so that frame on there is available on Thingiverse for printing for free. There's a lot of people that create other different styles of quadcopter frames and things. And so all you have to do is you go on the website and you can download a whole frame for free, essentially, that someone else has designed.
Yeah, that's pretty great. So, and then if you really just don't want to put, like, if you really don't want to go on the side of modeling things and you don't really want to go through the trouble of 3D printing at the library, you can get off-the-shelf frames. So the cheapest ones are you can get them off Hobby King and eBay, and that's just up to your ability to find things. You can search find as many things. How do you usually find online?
I
Frames.
usually actually, Hobby King.
Yeah. So
eBay for cheaper.
you can find them online, and they'll cost, what was yours, $40?
Yeah, that one was 40, but you can get, generally, if you get a frame online, it'll be 20 to 30.
Yeah. So you're really looking at $20 to $30 for a frame overall. And then you want to just go through some.
Yeah, I just
Examples.
threw up some examples of the different types we've been talking about. This one's all carbon fiber, PCB frame right there, and then this one's actually 3D printed. Some guy made that online, found it on a forum, so it's just a small example, something you can build with the library printer. So this guy here, you might have seen it online. It's the quad mover. It's an example of aluminum. One thing I didn't mention earlier is if you're building something more powerful, you might want to go with aluminum, just because like plastics can be flexing a whole lot, especially when you put something that's capable of, like this thing can go like 90 miles per hour. So, but yeah, that's the main thing. If you're going for more strength and power, definitely leaning towards aluminum. And yeah, just a simple basic wood if you just want to experiment.
So that's really, that's kind of all we got really on frames. Now we'll open up any questions. So you guys, if there's anything we said that you didn't get, if there's anything you also have questions on, I'm sure other people have the same questions. So is there anything you got now? Yeah.
Would you be able to model like an aluminum frame at all?
So you could model an aluminum frame, but you don't have the capability of making anything. So these, on this quad, all of these connectors are made out of aluminum, and we modeled those in SolidWorks, and then Carl and I took down the drawings and fabricated those in the machine shop out of stock aluminum. So you can model out of aluminum, and then if you have machine shop clearance, you can fabricate yourself. But you really have to take into account, am I going to be able to mill this on a manual mill? Or if you got clearance for the CNC, then maybe you can be a little more imaginative, but it's really based on your skill and your clearance.
Plus the time it takes too. Those
Yeah.
took us, we probably put 20 hours into just those basic parts alone. So
It takes,
so it's a process.
but you can. And if you really want to work on your manual milling skill, it's fun. So, yeah.
How do you get how do you get to use the CNC?
You
So-
take, so the first step is taking ME 250, which is the machine shop class. A lot of the times, if you've got machine shop experience or you need it for a club, which
Yeah. If you're in robotics
if you want to build aluminum stuff here and you're part of the robotics club, you can get ME 250 clearance. It's a 1-credit class. It's a bit of work, but you get to learn the machine shop. After you do that, that'll give you manual machining access essentially. Then you have to go and take a seminar essentially on CNC and then get certified in that. So it's a bit of a process to get CNC certification.
Typically, the seminars are about 3-day-long classes so Brian Jensen typically doesn't like a lot of people having it, so they're typically Thursday, Friday, Saturday of the end of finals week. So those are usually when the seminars are, so I've never been able to make them. But I mean, if you're around Thursday, Friday, Saturday, that's when he offers them. So yeah, that's how you get CNC clearance. Any other questions?
The CNC does print aluminum, right?
So it doesn't print aluminum. So anytime you're doing aluminum, how it happens is you've got a big block of aluminum and you machine stuff out of it.
Oh, okay.
Yeah.
So you get a stock sheet of aluminum, whatever you need, and then it'll remove material.
Yeah. So it's a subtractive process rather than an additive. So an additive process is like 3D printing where you're adding material, and a subtractive process is where you're taking material away.
Okay.
Yeah.
I just want to double check. ME 250, that is, you can't get that as an undergraduate, correct? You have to be in I'm sorry, not undergraduate, but you have to be in the professional school to be able to
I took it in my sophomore year before grad school winter term. And I did that because I wanted it, so I went to my advisor and I said, can you give me an override? And he said yes. And also if you're in robotics club and you go to your advisor and say, I'm in robotics club, they might give you an override as well.
Yeah. If you're in the robotics club and you need it for a club, which if you're here, you'll need it.
Yeah. You can say I'm building a quadcopter for the
Yeah.
robotics club.
That's super easy to get.
It's a time commitment. It's not like, here you go, like,
It is a difficult
it's like
class.
25 hours of like outside work.
Yeah.
It's
It's a lot. It's worth it, but it's a lot.
Any other questions? Quadcopters, frame design,
Terminology. We throw a
Terminology.
lot of like FPV and
PCB,
yeah, lots of
yeah.
acronyms in this world.
Words, yeah.
anything? Okay, so that's frame design. Next week, I'll send out an email to the members meeting or the members email about the next subject we're going to be going on, and we're just going to be going from there. And you can stick around. I don't know. Levi's has that one flying, so you can check that one out. You can see him fly, or if you have experience, you can fly it. And if you need to sign up as a member, you can talk to me. And that's it. Yeah. Do you also just want to hang out and talk about quadcopters? We're here for that. Thank you, guys. What was your name? What was it?